This question says, is memory ability before a meal better than after a meal? 10 people were given memory tests before their meal and then again after their meal. The data is shown below. A higher score indicates a better memory ability. So, some people say that when you get your stomach full after a meal, a lot of your blood goes to your stomach and not to your brain, and it's harder to think well. We know it's harder to swim. Don't they say you're not supposed to swim after you eat a big meal? Because again, the blood is in your stomach, busy digesting your food. So maybe the same thing is true for the brain. So here's a little test. They gave a bunch of people, 10 people. So this is like person one, person, oh, I wrote 10, person two, person three, 4, 5, 6, 7, 8, 9, and 10. And the person before the meal got an 87 on the memory test, and after the meal got the same score. This person two got a 51 score on the test before the meal, and a 46 after. Yeah, my circling is off a little bit. Anyway, you get the idea, right? This person did better before. So person two did better before the meal. Person three did also. Person four did the same. Person five did a little better before the meal. Person six did a lot better after the meal. Person seven did better before the meal. Person eight did a lot better before the meal. Person nine did better before the meal, and person 10 did better. So most people did better before the meal. So is this strong data, though, that memory before a meal? Is this strong data that memory ability before the meal is better than after? How can we figure that out? Well, this data is what we call matched pair or dependent data. Why so? Because this number and this number, for example, are matched. Meaning this 87, I don't just mean they're the same number, but they're matched here. In fact, in order to be clear, let me just pick something further down the line that are different. I'm saying like this 51 and this 46 are matched. Why? Because they're the same person. They're both the memory score of person number two. It's just their score before the meal and that same person's score after the meal. That's person two in both cases. We call that matched pair data because this pair of numbers is matched up to one person, and this pair of numbers is matched up to one person, etc. This is matched pair. It's also called dependent. Dependent means, connected, right? Like your dependents, your family is called your dependents. You're connected to them. So this is called matched pair or dependent data. Now, they could have done this experiment a different way. They could have said, look, we just took 10 random people, gave them a memory test before eating a meal. Then we took 10 totally different people and gave them a memory test after eating a meal. And then that would have been independent, right? So I'll just write that out. If it was two separate groups of 10 people, 20 total, then it would be independent data, not matched. Well, scribbling over part of the question there. So you'll get both kinds of questions in this chapter and on the final and on the fourth exam. So I just want to make sure you're aware of that. So whenever you get a question, you got two groups of numbers, you got to ask yourself, are those groups matched or are they not? In this case, they are, because the 51 and the 46, for example, are the very same person. So they're connected, dependent, matched, same person before and after the meal. But sometimes they'll do statistical tests and they'll just have two separate groups, 10 people and then 10 different people. You can see that it's advantageous to use matched pair dependent data, right? Because it's going to make more sense to have the very same person's test scores before and after a meal. It's going to be more meaningful, tend to get us to the truth of whether the food really does affect one or not, since it's the very same person. Whereas if we had 10 people here and 10 people here that were just different people, if the people did better before the meal, we might think it was the meal thing, but we might also think maybe those 10 people just had better memories than the other 10 people. Whereas if these are the exact same 10 people in both cases, we don't have to worry about that. We know it's the same people. So the only difference is the before meal and the after meal. It helps us hone in on something. So we like to do matched pair dependent data. All right. So, but there's both kinds of studies are done. So now let's go back. So what are we going to do then? Let's go back to the notes. As we look at the exam 4 notes, we're going to see it's right here to dependent matched pair means. That's what we're doing. See, independent was earlier. That's what we did earlier. That was section 10.2. This is section 10.3. Up here was section 10.1. Yeah. Now it's not going to say 10.1, 10.2, 10.3 on the final. So you really do have to learn to recognize it. So dependent matched pair means in real life, of course. So that's what we're doing. We're right here. The data is matched in pairs, actor, actress, couple, subject before and after, right? That's what we're kind of doing before and after the meal. That's us right there. Those are the kind of some of the phrases that you can recognize dependent matched pair data instead of 2 independent groups. We don't have 2 independent groups. So, all right. So coming on down here. First question for this study we should use. The answer is already there. It's going to be a t-test for the difference between 2, notice, dependent. There's that dependent word, right? I'll grab dependent. How do we know that? Again, it's from the notes. You go, okay, matched pair. What are we going to do? It says somewhere. Well, it does. It says t-test. So down there, this is where we're at. We're going to eventually do a t-test. So that's how we know it's a t-test for the difference between dependent populations, because this data is dependent. This group of numbers is dependent upon that group of numbers. They're matched up. They depend on one another. The 51 and 46 are the same person. So they're connected, dependent. All right, let's go through it. So what do we do for HO, H1, all that stuff? Well, it says right here, HO means the two mu's are equal. H1 means, mu1 compared to mu2 is greater than, less than, or not equal. So that's like usual. So we have right there, mu1 is equal to mu2. And then H1, mu1. Now, is it greater, less, right? We know HO is always equal. Always. HO is always equal all semester long. HO is always equal. And then H1 is always greater, less, or not equal. How do we know which one? We look back for some words. Did we see it? What are the words? Do you see them right here? Better. Is memory ability before a meal better than after the meal? Better. Better means, is the before greater than the after? That's what better. If something's better, it's higher, it's bigger, it's greater. So better. So greater. That's from the word better. So is memory with this? So this is before the meal, and this is after the meal. So the question is before greater, better than after? Right? Is before greater than after? That's what they're asking. Is before better, greater than after? Now, if they said worse, that'd be less. If they said different or same, that'd be equals and, for HO, and not equals. So that's how you recognize the words, right? Better, bigger, faster is greater. Worse, smaller is less. Different, same would be, equal here and not equal there, because the 2 things are different. They're not equal. All right, those are the different words you might see. Let's come on down. The test statistic. I've already got the answer here, but how do we get it? Well, we go to our calculator. What are we going to do on our calculator? We can go here to the notes again. It's going to tell you, put the data in L1 and L2. That's the first thing. When you're done, hit second mode, quit, and then do this stuff right here. So let me write that out. So we're going to go on the TI calculator. You're 83 or 84. We're going to go step number 1. We're going to go L1, L2 for the data. Well, it's kind of a weird way to say that. Let me just say data down L1 and L2. Data down L1 and L2. So that means this data right here. So this is going to be right here. This is L1. This is L2. So put this whole data down L1, put that whole data down L2. I'll do that in just a minute on my calculator. And then step 2. So you're going to have to hit, so put the data down L1 and L2. And once you've got that down, you're going to need to hit second mode quit. And so we'll go second mode. Oh, the mode. Oh, I should have done that better. Second, and then the mode button that has quit above it. Quit out of that, and then go on to step 2. And in step 2, you're going to go L1 minus L2 stored into L3. And how do you get L1? You have to hit second and 1. And how do you get L2? You have to hit second and 2. And store is a button. And then how do you get L3? You hit second and 3. So you're going to store L1 minus L2 stored into L3. And then step 3. So do that, sort of L3. And then you're going to go to t-test. So we're going to go, then we're going to hit stat, go over to tests, and go down to whichever one is t-test, which is number 2. T-test. And then when you hit t-test, you're going to choose, getting back to the notes here, you're going to choose data, and then mu0 is 0 and list is L3. So then you're going to choose data and hit enter, like that. And after you hit data, enter, then you're going to choose U0 is 0, which is a little weird. List is L3. How you're going to get L3 again is second and 3. And frequency is 1. Is 1. And then you're going to choose mu. It'll say not equal to mu0, less than, or it'll say less than u0, greater than u0, and then calculate. So we're going to choose, what is ours? Ours is greater, this, calculate, and enter. Okay, so it's a whole different process, isn't it? So I've written that out. I'll show it on the calculator. Getting that from, again, that all came from the notes, right? The exam 4 notes. It's all right here. And so you're going to go, so it's a weird thing. So when you have matched pair data, dependent matched pair data, which we do, these are connected. This group and this group are the same people before and after the meal. So they're matched pair. They're not independent. They're dependent. They're connected. What you got to do is you got to put the data down L1 and L2, quit out of that mode, then put L1 minus L2 and store into L3. Basically, you're taking the differences is what you're doing. You're saying, hey, take all the numbers in L1, subtract all the numbers in L2 and store them in L3 for me, calculator. And it's going to do that. It'll show you the list of all the numbers that put in L3. And then once they're in L3, then you're going to say, okay, now calculator, go to the t-test, go to the data mode. I forgot to circle the enter there. Go to the data mode, and mu0 is 0. What does that mean? That's the place that's saying the difference we're assuming the difference between the two groups is zero. Why are we assuming that? That's HO. HO says they're equal. Remember, the null hypothesis assumes they're equal. So if they're equal, the difference is zero. You don't have to memorize it. Just use the notes. Always put a zero there from u sub zero. It just means the mean, that's a Greek M, the difference, and the sub-zero is the hypothesis, right? Sub-zero comes from the sub-zero here. If they're really equal, then there's no difference between them, right? If two things are equal, there's no difference between them. So the difference between them we're assuming for HO is zero. The list of their differences is actually in L3, right? Because L1 minus L2, their differences are stored in L3. So the list of their differences is now in L3. Got to make that L3 second and 3. Frequency is 1. We just always make that 1. Where ours is greater, I'm getting that from H1. Greater. In fact, let me just show that. Greater. Right there. And then calculate. And we'll get our numbers. So I'm going to go do that right now. All right, there's the calculator on the screen. And so let's go through that process. So here we go. I'm going to put those numbers in there. So I'm going to go to Stat, Edit. There's L1, L2. You know how to get there. I've done that a million times. Clear out L1. Go over here. Clear out L2. Put the data down, L1. So what do we got? 87, 51, 51. Try to do this quick. 71, 76. 65, 76. 71, 63. 65. And then the second list of numbers, 87, 46. 49, 71. 73, 78. 73, 58. 60 and 61. Okay, I'm going to double check my numbers, make sure I've got them right, because it's easy to mess this up. I don't want to mess it up. So I'm going up to the top here. So what do we got? 87, 51, 51, 71, 76, 65, 76. And 87, 46, 49, 71, 70, 78, 73. And the last three. 58, 61, 71, 65. Looks good. Looks good. Okay. And then what are we going to press after all that? The notes tell us we're going to have to go second, quit. In fact, let me clear. Because that's where you know how to do all that other stuff. So now, so back when I'm on this screen, let me go back to where I was. So I'm in this screen, right? What do you do at this point? You got to get out of this mode. How do you get out of this mode? You see the quit, the blue quit above the mode button. To get anything blue, you hit the blue button first, right? Hit second and mode, which does the quit, the blue quit above it. You quit out of that L1, L2 entry mode. And now we're going to go L1 minus L2 stored in L3. How do I get L1? Second 1. See the blue L1 above the 1? Minus, subtract, second 2 gives me the blue L2. Store. Now the store button is over here by the on button, right above the on button. STO, store, stored into L. So the difference between L1 and L2, the differences between all the L1 and L2 values will be stored into second 3, into L3, enter. So there we go. That list, you don't have to do anything with that number, but it's telling you those are the differences it just put into L3. See those numbers right there? It just put them into L3. I'm going to go show you. You don't have to look at it. It doesn't matter at all. Well, if you went and looked at it, you'd see it. But I'm going to move on with the problem. Now what am I going to do? Now I'm going to hit Stat, go over to Test, go down to T-Test. hit enter. And now I'm going to move over to data because I have a bunch of data in L3, right? Move over to data, enter. See how this has got a 0 there for U0. That's great. L3s aren't now. Let me suppose it didn't already have an L3. I'd have to put an L3 in there. How do you get L3? Same way we did a minute ago. Second, 3. That's an L3. Frequency's 1. Mine is greater. See, it's already on greater over there. And go down to calculate and enter. And so there is our test statistic, 0.986, and our p-value, 0.1749, it would round to. There we go. Let's get back to the problem then. Okay, so now for the rest of the question. So there is the test statistic and the p-value that we just saw from the calculator. So again, here's the steps over here. If you missed those, there's the steps. One thing I forgot to put in is you do have to hit enter right here after you put in L1 minus L2 stored in L3. But there's the steps. They're in the notes. So you come on down here. So there's my p-value, and when my p-value of 0.1749, how does it compare to the alpha level? I don't remember what was the alpha level. Somewhere up here. There it is, alpha 0.01. 0.01. So clearly my p-value is greater. So now what does greater mean? What do we do for a greater p-value? Well, in case you're a little unclear, you know what you can do is you can always go back to the exam 3 notes. Let me show you right here. Yeah. So this is the exam 3 notes. Okay, I'm in trouble here. So this is the exam 3 notes, right, that tell us how to conclude a conclusion of a hypothesis test. That's still the same. Ours is greater. Our p-value is greater. So what does greater mean? Right down here, p greater than alpha, it'd be this one right here. What does that mean? It means fail to reject HO, keep HO, weak evidence. Fail to reject HO, keep HO, weak evidence. So I'm going to say, oh yeah, fail to reject HO. Instead, keep HO and weak evidence. So I'm going to keep HO. Now, what does that mean? Well, remember, HO and H1 are the 2 attorneys that are arguing in the court of law, right? I don't know where it went, but let me put it back where it was. This attorney is saying mu1 equals mu2, and this attorney is saying mu1 is greater than mu2. Oh, I had it up here. That's right. Anyway, those are the 2 attorneys. So, we either believe attorney HO or we believe attorney H1 based on the evidence. What is the evidence? The p-value is what the calculator's evidence tells us. What does it say? Keep HO. So we say, oh, okay, HO is the one. So I'm going to take HO, bring it on down, keep HO. What does HO say? Mu1 equals mu2, equal. So our conclusion is that memory ability before the meal is equal to memory ability after the meal. So it turns out, you might say, was that really right? Well, because you look, most of these numbers like before were like, these were the same, 87, 87, but 51 was bigger than 46. That person 2's memory ability was better before. And person 3 was better before. Person 4 was even. 5 was better before. Now 6 was way better after. He threw the data off. He or she threw the data off a little bit. 7 was better before. 8 was way better before. 9 was better before a little bit. And 10 was better before a little bit. Most of the people were better before the meal, a little bit. Problem is that it just wasn't strong. One person was actually better after. So the fact is the evidence just wasn't strong. That's why we say weak. There was some evidence, yeah, but it just wasn't strong. It was weak. So we say, so our conclusion is, yeah, there's not strong enough evidence to really show that your memory is really that much better before the meal. We don't really think mu1's greater than mu2. We don't really agree with attorney H1 that the first memory before is greater than memory after. There's a little evidence, but we're going to stick with the original assumption that the two memories are basically equal. So that's why we say it's pretty much equal to, because the evidence was too weak. And so there we go.